We are here today to learn more about how we can make our APIs great again, with the possibilities that GraphQL and Apollo give us, it's quite an easy task. But let me first start with introducing myself. My name is Konopka, and I'm a front-end developer in Montreal, which is a software development agency based in Wrocław. And I'm really, really happy that I can be here at a conference that is dedicated to JavaScript, as it's my passion, and I'm really happy that I was given a chance to talk to you guys about the things that I was really digging into for the past couple of months. Yeah. This is me. I think that probably most of us here are developing JavaScript applications on a daily basis. And we are doing so, for example, by creating APIs, which define how our front-ends and back-end can communicate. And I think that we are a little bit stuck in the perspective, in this classical approach of doing so. And I would like us today to start with a blank page and see where we can get, try to think about how we could do it differently, maybe more elegant, or maybe it will give us some handy features. And to do so, we will need a real-life example. And surprise, surprise, it will be an election poll app. And here we will be able to show some candidates, vote for them, and see their scores. But when we would like to think about what we actually need to define an API and to have a fully functioning application, we have to start with thinking about the data inside the application. And this is actually some real-world entities that are mapped inside our app. So for example, in this case of an election poll app, it can be a candidate or a vote. And as we can see, there are some attributes connected with each of such entity. For example, candidates have first name and last name and information about age. The next thing that we can see here is that those entities have a connection between them, some relations. So for example, the vote belongs to, somehow is connected with the user that gave that, and the candidate it refers to. And apart from data, we have to also think about the actions that are happening between front-end and back-end. So our front-end, to show something on the screen, it needs to fetch data from somewhere. So, for example, we would like to show the current winner of our poll. And it will be actually Donald Trump here. And maybe I will go to that. As we can see, we are, for example, we need to show first name, last name, and the photo of current winner, and we need a way to ask for it. And the second type of action that frontend actually can make is to change some data on backend. And we need that because we want our changes to be visible by other users of the application. So for example, in the election poll app, we can vote for somebody, and we will get some results by doing so. So probably most of you already know where I'm heading. So the way we defined the API for our election poll app is actually GraphQL. And it's a query language that was designed by Facebook fellows. And you can use it actually to define your APIs too. It somehow relates to SQL, as they are serving similar purposes. And we will be digging into that and see what handy features it can give us. So let's start with Schema, because Schema is the main building block of each GraphQL-defined API. And as we can see, this is the place where all those real live entities live. So we have a candidate and a vote here. This is also a place where you define how front-end can query backend and how it can mutate the data. What is more, it's actually an API contract. So with that in place, you will no longer have problems with front-end and back-end integration, which might be really bad sometimes. I have experience. And what is also important is that it's not kind of documentation that lies somewhere and it's never looked at, because every query and mutation in our system is validated against that. So it cannot get outdated just because it's used all the time. The second thing is that you can see that here we have types. So each attribute has a type connected with that. And who like type systems? Oh, more? Okay, I was expecting more. So types are a really nice thing because they are allowing us to sleep at night sometimes because of its powerful feature of scaring the bugs away. And it's nice to have an API contract that is typed. As we also can see, we have a way to show that something is not nullable. For example, that we will always get here an ID, and there will be no nulls there. And we have also a way to show that something will be a list. So here we have a non-nullable list of votes. So that was a schema of GraphQL. And now we will learn how to query such an API. So we've already seen this current winner query. And it is our way to get data from GraphQL backend. What is more important is that actually can give us possibility to reduce our payloads. Because probably most of you already realize that in GraphQL you have to explicitly tell what fields you are using. So for example, if we only care about an ID of a current user, we are asking only about that. And we actually, probably most of us already seen that we are having this mobile theme across many presentations, and it also pays to that. So, I mean, if you want to make your mobile users happy, you should also make your payloads smaller. The thing that I personally really like is how GraphQL allows you to have a really nice evolving API. So for example, if you add in your schema here a website address for any candidate, and then you add it to your queries, each frontend has to explicitly tell that it is using a field, and you will no longer have problems with too many data that is spoiling your frontend, which is not ready to handle and to consume that. And this is the place where we draw the big guns, and these are the nested queries. So what if we would like to have authors of all of the votes that were given to a current user? In the classical HTTP, in classical REST approach, you would probably make a lot of HTTP calls to achieve that. And in GraphQL, it's possible to get all of this data in one single request. And this is something that also is playing a role when we are talking about mobile users. And the thing that I already mentioned, that each of the query is validated against schema. So if we would like to have a cat name of current winner, we wouldn't be able to do so if there's no such attribute in the schema. So GraphQL will yell at us if we would like to do so. Okay, so that were queries, but we are not done with rock and rolling with GraphQL. We also have a way to mutate data, of course, and if we would like to vote for somebody, we can do that using mutation. And the thing that is important here when we are talking about mutation is the fact that we can use variables, because when we have some dynamic arguments that we are passing to our mutations, we should be able to do so. Of course, we also have this feature that we are defining what we would like to get back in our response, and we can also only get ID or any other field if we would like to. And mutations are also validated. Okay, so we know how to query data, we know how to mutate that. Is that it? Not really. What about the case when we would like to have real-time updates inside our application? So, for example, here we are updating the number of votes for a candidate. Can GraphQL help us with that? Yes. Subscriptions are made for that. They are not yet part of GraphQL spec, but Apollo, for example, is already implementing them. And they are actually quite similar to queries, but instead of having one-time response, you are subscribing and you get an information each time an event is happening. So underneath it is using some technology that allows for server pushing to the client, and it's usually WebSockets. Okay, so I was telling you a lot about how we can define our APIs in GraphQL, but you still don't know how to exactly start with that and use that on daily basis in your applications. And here comes Apollo. Apollo is an open source GraphQL front-end client, and it allows you for easy query management and have some nice features that I will tell you about. And the first one is caching, because Apollo client allows you to store all of the results that you got from your queries and mutations inside one normalized store. So there, all of the items it knows about are stored under their IDs, and each time you will learn something new about those items, they are updated in the in the cache and then propagated to the whole app. What is more, it integrates easily with all of the popular frameworks like React, React Native, Angular, or Vue. And you can also use it with vanilla.js solutions, so it's for everyone. And the thing that is also really, really nice for me is how it handles optimistic UI. Have you heard about optimistic UI? Can you raise your hand? Yes? Okay, so I will tell something more for those who haven't heard about that yet. So around 95% of requests to a nice functioning API results in a successful way. And sometimes it's a better user experience to show that a request was successful before we even know that it was. And in Apollo, it's really easy to manage those changes inside our application state, because if we are doing that manually, it can get pretty messy, because we have to somehow revert the changes when we know that, unfortunately, an error happened. Okay, so I prepared you an example how we can use it with React. As I said, we can do it also with Angular, but I think that there are many React developers here, so it's okay to do it so. And as you can see, here we are defining a query, and we actually almost have done that already when I was showing you GraphQL queries. And here we are connecting it to our component. And an important thing here to see is that we are doing it by using higher order components, about which Bartosz was talking already while talking about Recompose. Also, apart from information about current winner that we have inside our component, we are also getting very useful information about errors that happen, or that the request is currently in flight and we should show some loading states, and many, many more, but I didn't have a time here to tell you about all of them. Okay, so we know how to deal with GraphQL on front-end side. It looks pretty neat and elegant, I think. But what about the server? Do we need something there? So we definitely need a GraphQL server. And it can be written in JavaScript. And as an example, I will show you how we can do that using Apollo server, but it actually doesn't have to. In the project that I am currently working on, we are using Ruby GraphQL server, and everything plays nicely, but the JavaScript implementation is the major one, so most tools are made for the JavaScript implementation. So what do we need to actually make a server, a GraphQL server? So we have to have the same schema, because as I said, it's the most major thing when we are talking about API that is defined by GraphQL. And we have to write resolvers. What are actually they? Resolvers can give us the possibility to teach GraphQL server how to get data for each of the queries and then for each of the type that is appearing in them in a tree-like fashion. So for example, we have to know what we should return, what type of candidate we should return when we ask for current winner, and then when we ask for some fields on this candidate, we have to know how to get them from this object. And we also have to have a data source that we will ask to provide us with data. And it can be DB, and it's actually, in most cases, it is database, but it doesn't have to. We can also, in our resolvers, we can also ask another REST API or GraphQL API about the data that we want to put into our response, GraphQL response, or we can use some static data, for example, when we are writing a mock GraphQL server. Okay, so of course there are some downsides. And the main and major one for me is connected with the fact that GraphQL is adding another level of abstraction to your stack, and we have to always think about that and carry this abstraction with us everywhere. So for example, it's not so easy to make a call to a GraphQL server when we have only command line and URLs. It's not so easy, and that's why we have all of these tools like Apollo client to make it easy for us. And the second thing that is also connected with this abstraction is the fact that when we are using GraphQL, we are not utilizing the caching that is built inside our browser. So for example, Apollo is making its request using one endpoint and post requests. So we cannot talk about any caching by doing so. Okay, so if you want to learn more about GraphQL or Apollo or Relay, which is a Facebook implementation of GraphQL client, you can visit Awesome GraphQL repository. There are many resources there. And I would like to finish this talk by saying a thing that probably I'm saying on each of my presentation, and it's always think about your problems first, and only when you realize what are they, choose the solutions and the tools that you would like to use. And if you would like to improve your mobile experience or your development experience or maintaining your application, I think that you should give GraphQL a try. Thank you. This is my Twitter handle, so you can always tweet at me, and my blog is also there, kernel.pl. And are there any questions for me?
There is any GraphQL tools to integrate GraphQL schema with the backend written in the static typing language like Java or C#?
So I don't know anything about Java implementation, but there is one implementation of GraphQL server in Java, but I'm not really into that, so I cannot tell you. But I know that there, for JavaScript implementations, there are some tools to bring the static consistent between the schema and your flow typing or TypeScript typing. But I cannot tell you anything about Java, unfortunately.
Okay, so this will generate me the data structure on the backend and the same on the frontend with the flow or TypeScript, right?
So yes, you can use the typing that is coming from the schema to make types on JavaScript side. And on backend, if it's in JavaScript, it's the same way. And if it's on in other language, I actually don't know exactly.
Thank you.
Thanks.
I was searching NoSQL database. I found only MongoDB in community. I have this question. What is the difference between Express and MongoDB and Apollo and GraphQL?
Okay, so at first I would like to tell that I'm not actually a backend developer or even probably a full stack one. The fact that you are having an SQL database or a NoSQL or whatever you would like, it's totally separate from the GraphQL part. And as I said, if we are creating a GraphQL server, then the way you get your data is totally up to you. So you can, for example, use either MongoDB or PostgreSQL, and it's totally transparent. Yes. And the GraphQL part starts really on the API level. Either it's a separate instance of Node.js server, for example, or it's integrated in your backend. But it starts from there, and frontend also uses that.
My question is about support. Because you say that Facebook use it, so I think that will be bigger support in future about this.
So we cannot actually talk about any support because you just get a function and you can do whatever you want. So you can use the tools that are made to use MongoDB database or any other you would like.